Vic, is it already live or we can pause and then start?
It is live now. Just went live. So please go ahead. You can start.
I'll wait till host join. Can we pause it, or it's not possible to pause, Vivek? Live stream?
It's live stream. It'll be live. So it's fine.
Okay. So hello everyone. We'll wait for a couple of more minutes till everybody join. We are waiting for everyone to join. Is there anyone who joined this meetup first time today?
Yes, my name is Hari. I joined this first time.
Hello, Hari. So, do you mind sharing how did you heard about this group? And
this is hard. Actually, I signed up for this very long back, but I forgot about this. But one of my friend, when I was discussing with him whether we can do group learning by Google Classroom or something by sharing something, then he suggested me this to join.
Okay, nice. And did you join Slack group and you know how to?
Yes, I joined Slack group, but I have not yet used it. Yesterday evening only I just joined.
Okay, okay, all right, nice. Welcome. Is Anand this?
And by the way, what is that we discuss in Slack group usually?
So basically, in Slack group we have a different channel for let's say one for this meeting as well as one for the daily lead core practice that we do. There's a channel for finding the study group based on the location. There are channel for specific topics, let's say system design, and so there are a lot of various channel there, and a lot of announcement happen there. People discuss problem there. There is a channel for the 30 days of lead core right now, I think. Where people discuss all the problems and what they are doing.
Oh, good. I will check that. Thank you.
Yeah. Someone else was checking. Yeah, please go ahead.
Hi, everyone. It's Hanif. Is my mic working?
Yeah. Yeah.
Okay,
right.
Cool.
Anand, you have your hand raised. Do you want to say something?
Yeah, you were asking who's been here before or who's here for the first time.
Yeah.
On the same meetup, I went to one where they pair you with someone else, and then you just trade coding problems for an hour to an hour and a half, just with one other person. So you essentially interview each other. That's the only one I've been to. And I'm not sure if it seems like this one is a different format.
Yeah, so this one, basically, this meeting used to happen in person. And we started doing it online. Here we discuss various topics. Most of the time it's a coding problem, but we do discuss design problem, resume overhaul, or another problem, leadership principle question, and how to answer this and this kind of stuff.
That's great.
So the last thing I said is that mostly in Amazon, and I think now various companies, right, there will be one interview for the leadership principles. So we have some session on that as well. Okay. All right. So welcome everyone. Today, Hanif is going to talk about string-related problem. Is that correct, Hanif?
Yes.
Right. And to you, Hanif.
Yep. Thanks.
Just hold on. Can you start recording as well? Let me. Okay. I started recording. Go ahead.
Okay, sure. Yep, so we're discussing strings today. I just posted a link to the handout. So in case everyone wants to follow along, and I guess I will also share my screen. Okay, just 1 second. I think I have to my permissions. Okay, I might drop for a second because I have to like give Zoom the permissions to share
Yeah.
screen.
Sure.
Okay. All right. Let's try sharing screen now. Okay. Is it visible?
Yes, we can see.
Okay, cool. Yeah, so let me pull up the problems. Okay, so I posted the handout as well in the chat, and you can follow along here as well. So the first problem is to find the longest substring without repeating characters. So I guess I'll give everyone maybe like 1 minute to just read it and think about it, and then we can start discussing. All right, so does anyone have any ideas on this first problem?
Yeah, probably a simple brute force would be like passing all the substrings and until we find a the answer is ABC with length 3. Okay. I'm assuming like run a for loop for every 3. Okay. I'm not sure.
Yeah, so the problem is to find the length of the string. So it's not, in this case, it's not like a fixed length.
Okay.
You want to find the longest substring which does not have repeated characters. So every character in the substring would be unique. Sorry?
Hey, this is Sai. I'm thinking about we can use a sliding window approach to to handle this problem.
Yeah.
Maybe 2 pointers. So both of the pointers will start at 0 index. Okay. Or maybe start an end pointer. So start pointer will start at A and end pointer will start at B, somehow, like when we move the pointers, we have to remember like what are all the characters that we have seen so far. So maybe we can use the hash map. So let's say if we use a hash map, then I'm gonna put, okay, so I seen A, so I'm gonna put A into the hash map, B into the hash map, C into the hash map. And then my pointer is at the second A now. So now this A already exists. So I'm gonna record the result. Okay, I'm gonna record the start and end point, I mean like the left and right, maybe 0 and the second index. So that will be, I'm gonna do substring and then I'm gonna put that into the result, like temporary result for now. And I have to move my pointers. I mean, see, ABC is one answer, and then BCA can be another answer, which means I have to remove the first, I have to increase my start pointer from A to B.
Okay.
That is what I'm thinking. So in that way, we can, you know, play with our pointers and record the maximum substring as we go through until the end.
Yeah, exactly. So that sounds very good. So in case everyone's not familiar with the sliding window technique, maybe I'll just explain that real quick. And then Sai, if you want, you can maybe try coding this if you want.
Yeah,
okay.
sure.
Yeah. So like he was saying, so this is kind of like a classic sliding window problem. And sliding window, it's a common technique for like array problems. Yeah, array problems, as well as string problems. Strings are like, you could think of as like a character array. And basically the idea is that you'll have two pointers, like he was saying. So if we take this string, so you can have like a start and end pointer at 0 and 1. And basically you want to, like this, the substring between the start and end pointers is your window. And the condition that you're always trying to maintain in this problem is you want to have unique characters within the substring. So you could use a hash map to do that. And basically, anytime you satisfy that condition, when you have unique characters in the substring, you can advance the end pointer to find a longer substring. And then as soon as you get to a position where you have a repeated character, like let's say this substring A, B, C, A. So now the A is repeated. So in this case, you want to shrink the window. So you would increase S by 1. Okay, and then BCA is unique again. So then you would expand the window again by incrementing the end pointer. So if you do this, you'll get the length of the longest substring. I think we're having, I was looking at the calendar, I think we're having a full session in 2 weeks on strings and sliding windows. So we'll probably go into more detail about that in that session. But for now, so Sai, do you want to, you can either share your screen and like code this in whatever language of your choice.
Yeah, sure. I'm gonna do that right now.
Okay. Hey, I have a question there.
Yeah, sure.
So is that right? So this approach would have complexity like order of n square?
Right. So
because like if I start from A, I'm looking at the rest of the string. And then if I start from B, I'm looking again at the rest of the string. So
it's actually not n squared. So like the sliding window approach, you have these two pointers and you're like either contracting or expanding this window. And if you think about it, you're only doing one full iteration through the input string.
Yeah, because you only check each character You only check each character once. Even if you move pointers, you're not rechecking what you've already checked.
Right.
That's why it's ON.
Yeah, you could think about like some of the edge cases also, like if, let's say that all the characters are unique in the string, so then you'll keep incrementing your end pointer, and it'll just end up being the length of the whole string. And then the other case you could think about is like, let's say if everything is the same character, you would have to increment both. I mean, depending on how you implemented it, the way I implemented it, I have it a condition where start is always less than or equal to end.
Right.
But either way, like you're, in any case, you're only going to do one full iteration through the whole string. So it'll be order of n.
I see.
Yeah.
Okay, thanks.
Okay, so Sai, so I'll stop sharing my screen, and then Sai, you can share your screen.
Yeah. Let me know when you can see this.
Yeah, I can see.
Okay. So so actually hash map is not needed. Hash set is absolutely fine for this. So what I'm thinking is, so maybe we need, I mean, the base cases, right? The base case, maybe, yeah. So if S is null, like the given string, or if it is actually 0, so I can actually return 0. So that's the longest substring, the base cases. And so I need, so I'm going to take this example. So I need 2 pointers.
Would you be
So
willing
one is
to increase the size?
or the
Would
font
you be
size?
willing to increase the size of the screen? Yeah. Or just Control
okay, so
plus.
let me take some word. I know it will be hard in the lead code, so I'm gonna write it on the word pad, you know, for simple. So let me know if you can actually.
You can like.
And I'm gonna increase.
I think you can just
Thank you.
the HTML page. That way you can write it in lead code itself.
Yeah, if you want to use lead code, you can also like try like zooming in, like Control plus.
Yeah, okay, that's fine. I think I'm okay with this.
Okay.
So, okay, so the base case, you know, if it is null or the length is 0, I'm going to return 0. Okay, so here is the example that I'm taking. So start, I'm going to have a start here and then on here. So what I can do, I can move only one pointer. So I'm planning to move my end pointer until I find the duplicate character. If I find a duplicate character, I'm going to record the result. So the result is ABC right now. And then, okay, now I found a duplicate, so I will increase my start pointer, the other pointer from the left side. Now, again, now there are no duplicate characters. Again, I will record the result. Okay, and then I start moving my end pointer. I think it will make sense if I, you know, if I put some coding here. So let me take, you know, some simple set. So this will be a simple character. So I'm gonna say set is equal to new hash set. So as I said, I will be needing a 2 pointers. So I'm gonna say, okay, it's horrible. Int begin, I'm gonna say begin, and then int end is 0. So I just need to do until my end pointer reaches the end of the string. So until that, I just need to move along. So I have to get the character. What is it first? So s dot char at end. So I'm taking that specific character, which is A. So that does not exist in the set. So I will check if it exists, if it not exists. So 2 cases. So if, you know, if set contains this specific character, right? If it's not contained, or if it contains, the 2 things, right? If it contains, if it does not contain, or if that already exists, which means there is a duplicate. Okay, let's say if it's not contained, I simply need to put that specific character into this set, right? And then I move along. So put that into the set and then move along. Let's say if that already exists, I have to record the result, right? So maybe I'm gonna maintain a global max. So I'm gonna say max result is 0. So I'm just gonna record the result. So max result is equal to map dot max of map result comma set dot size, right? So I just need to get the size. So this will be the max result. So which means the first time, let's say, I'm gonna write the code. We can actually walk through the code. Okay, so I record the message. I record the result, and then I have to start moving my begin pointer, right? So which means,
So
I
what is
have to remove that. Yeah.
Yeah. So what is the condition where you increment the start pointer or the begin pointer?
Yes. Actually, here I have to increase my. Thank you. Yeah, I have to increase my end pointer. And here I have to write. So I just recorded the result right now.
Mm-hmm.
And then start moving my begin pointer. And make sure you remove this duplicate from the set, right? Duplicate from set as well, right? So the first thing is you have to simply remove that specific character. I mean, the character at the begin, right? And then simply do begin plus plus. And what you can do.
So why is that it begins? Could that be a repeating character which is at the second position?
Yeah, that's my concern. Like, for example, let's say you had A, B, C, and then the fourth character was B.
Yeah, exactly. Okay. So, okay.
You
so,
don't want to remove.
Yeah, right. So let's say you're saying this is the input, right? Mm-hmm. Okay. So if we walk through the code, the character is at A set is empty. So your set is empty. So you're going to add that, add A, and then increase your n plus plus, right? And the next time you are at B, right? So here is B. So B does not exist in the set. So it will add that to the set and then increase end pointer, right? According to this logic. And then you are at the this third index. C is not exist in the set. So it's going to add that to the set and then increase the pointer, right? Okay, now again, end plus plus. So here you are at B. So you got B right now. So it is in the set, which means it comes to the this else condition. So it will record the max result. What is the set dot size, which is 3. So for now, oh, we need the substring, right? Oh, I think we need the substring, but I'm actually returning the.
You only need to return the max length, not the substring.
Oh, max length. I see. Okay. So here, ABC, I mean, I'm returning the length of 3. Okay, right now I just recorded the result, the max result, which is 3. And what I'm doing is I'm actually, here is the begin, right? So I'm actually removing this begin. I'm removing A, sense. But I'm doing, right. Now I'm doing begin plus plus, right? So which means I'm removing A, and then I'm doing begin plus plus. Now still this begin exists. We are not moving end, so which means still this B exists.
Okay, then it works.
Right, which means, yeah, right. Mm-hmm. So yeah, and then it removes again, and then it's gonna, move this. Now it's not exist, so it's gonna add it. So yeah, so and then here after this loop, you just need to return the max result. But we can actually walk through few examples. So let's take
after you remove it, would you add them back? Like for example, you have one B, right? And then you remove it and you would add the second B back to the set. But it seems like you only removing it.
Right. So the sliding window approach, I mean, the same approach, we can use this approach for multiple problems, the sliding window approach. Make sure you remove the elements from for the begin only. You know what I mean? Like from the begin pointer, try to remove the characters from the begin pointer. So that will make things easier. Okay, so when you are here, so, okay. So your end is at this position, right? At this position. So now B already exists, which means you have to move your pointer until here, no matter what. Which means you don't need B and A.
Oh,
you can
but
simply remove those.
Still at B.
Yeah, I'm not moving end pointer yet.
Yeah,
I'm not moving end pointer yet, right?
If
So
you
now,
wanted to do that,
okay.
If you wanted to do that, you would need to use, I guess, a map instead of a set.
Yeah.
So that you know the
Yeah,
position.
I mean, there
of
are
the
multiple
character.
ways.
But
Right.
there's an, if like, look at, if the string is all unique, then you return 0, look like all the character in that string is unique. You don't.
Yes,
I see what you're saying.
That's the good catch, actually. Yes.
Basically,
Sorry, what are you saying?
Max result, we are just counting in the else. What if we never go in else?
Right. If set is not empty, I'm gonna say max result. I'm gonna catch, catch the. Yeah, I think I missed that point. Right, if it is not empty, I'm going to record the max result and then return the max result. So in this case, if everything is a duplicate, I mean, like if I have B, 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 then I'm gonna make sure I'm gonna return 1 in this case.
Yeah, I just wonder why don't you record the max result in the if statement? Because in the if statement, the guarantee everything is still unique, right? It's unique.
Yeah,
so
yeah. I mean, I can actually, put outside the, Can I put outside? Yes.
Yeah.
Or maybe not. Wait.
I mean, you can put outside also, but I think the suggestion is to put inside the if, and that is the most useful way to put it. The reason is that, whenever you are incrementing, basically you are recording. Yes, you are recording the result.
So that I don't need this anymore.
You don't need anything else. Yeah, yeah.
I see. Yeah, that's a good one. Yeah, that's a good one. Or do you want me to, go through one more example? Go through the code once.
Yeah, that would be helpful.
Yeah. Okay. Sure.
Okay. Yeah. Sure. Let's do it. So I'm going to take A, B, C, B, A, B. Right. So this one. So let me put it this way. So I'm going to. Okay. So here is the start pointer. I mean the begin pointer, and here is the end pointer. Okay. So the idea is to use the sliding window approach, which means you just make sure you move these, pointers. If you think this is the start and this is the end pointer, so in your string, you just move, these brackets. That's it. So this will be O of n only. It is not O of n square, right? So you will move from start to end. That's, I mean, like from the starting of the string until end of the string. That's it. So this is O of n, so it's not O of n square. So the logic that I'm trying to use, you simply use a simple hash set and make sure you, if you find a duplicate, then you update the result and then remove and then come from the begin. That's it. So here what I'm trying to do, so I'm at the end, which is here. So the first character is at, the first time it is A. So we have an empty set. So empty set, it does not, A does not exist. So it's going to add that. And then I simply need to increase this end pointer. So it moves to here. And then this B does not exist. Add it here, move to the next pointer. C does not exist, add it here, move to the next pointer. And B exists. So when you find this, you just need to play with the begin pointer until you reach unique elements. I mean, until you remove the duplicate. That's it, right? So once you find that, you record the max result. Once you find B, you record the max result. And you start removing A, you start removing B, right? Until you only have a non-duplicated element in the set. So you remove A first, and then you remove B, and your end is at still B, right? So this does not exist in your set right now. So you will simply add it, and then move your end pointer, which until to here. So again, now end is A. A does not exist in the set. It's gonna add A, right? And then you move your end pointer. Oh, here is the end pointer. Now B exists, right? B exists here, which means there is no use until here for you. So you can simply remove the elements C and B. Again, make use of begin pointer. So you do remove C, and then remove B, and then do B, begin plus plus, remove B, and then add just A comma B into the set. And then you record the size again. I hope I kind of made it clear. I'm not sure.
I just have one question, Sai. I was wondering, when you remove B, right? You said you'll remove B. Once you remove B from the set, will you be adding the B after the C back into the set?
So once I remove like this pointer, right?
The
Like
first
this
B,
B?
yeah.
So once I remove this, so basically, yeah, definitely I have to add this end, right? See, I'm just playing with begin pointer until I remove the duplicate. But your end pointer is constant. End pointer is right here. End pointer is right here only.
I think what she's saying is that every time you're in a situation where you're moving the begin pointer over, the last thing you end up doing is you end up deleting the duplicated element, and then the very next thing you do is you add the duplicated element, the originally duplicated element, back into the set. So we're trying to just shorten that last operation by not deleting it out from the set and immediately adding it back.
I'm adding, if you see, right, I'm adding the end pointer back, but I'm deleting the begin pointer. So two different pointers, because the reason that I'm deleting B in the second position and then adding it on the fourth position is because from here I could have CB, B, A, right? Which is actually bigger than this, so, right? You know what I mean? You have to add
the set
this
is
back.
the set is not ordered. The set is not ordered. So if you remove an element and then add it straight back, you're doing a couple operations that you don't need to do. I think all she's saying is that if you're moving the begin pointer over to the spot that's right past where that duplicated element,
oh, I see.
First instance of it is, you're taking it out of the set and then you're putting it back. So it's not a big deal. Like, I don't think this like increases the number of operations that much, but
Yeah,
actually, that's a good point.
It's probably not a big deal like she was mentioning, but
So-
yeah, I mean, yeah.
But one thing I can think, so you're never guarding for begin to be less than or equal to end, right? So like, just thinking like, what if your input string was like A, BAC, let's say, like would that still work?
So you said A. Can you tell me
And then
again?
BAC.
Right. So here is my begin and here is my end. So I'm gonna move my end. So here is my empty set. So I'm gonna add A first. It does not exist. I'm gonna move move my end pointer. So A already exists. So I have to delete this A, right, which is at begin, and then do begin plus plus. So your end and begin is still here, right? So you will delete this, but you already recorded the size so far, which is 1, set dot size, right?
Yep.
And then you do end plus plus again, right? So now its set is empty, so you're gonna add A again. So, and then you do end, end plus plus, so which means end is right here. And this A already exists in the set. So now you have to delete at whatever there in the B and then move and then do begin plus plus. But you try to record the size again. So you delete this and then do begin plus plus. And then you add at end pointer, which is A. So again, you add it A. And then you do end plus plus. And then B does not exist. So you add B. And then you do end plus plus. Now A exists, right? So you have to record the size. So right now the size is 2.
Yep.
So you do end plus plus. So your end is right here. Oh, now it exists in the set, which means at B, you will remove whatever there in the B, which means A is there. So you will remove this. And then you do begin plus plus, which is B is right B right now. So, and then A does not exist in the set right now. So you will add that to the set and then you do end plus plus, which means right here. So right now C does not exist in the set and then you add it to the set and then you do end plus plus. So, and by the time the end is actually less than length, right? So end is right here. End is right here. So less than length. So you will record the size, which I'm actually recording right here.
Right. Okay.
So the size is 3 right now.
Yeah, I forgot that you were removing every time. So I guess you wouldn't have that problem. Okay, cool.
But someone mentioned that approach, like directly going to that specific index. So I think that's a very good approach. Actually, we can jump right there. If we have like A, B, C, A, B, right? Maybe, okay, let me take erase this a little bit.
Well, I mean, there are 2 ways to, I think that if you do a strategy where you jump straight to the next index, so like, you know, here you have 2 B's already. One is at position 1 and the other one is at position 3 in your array.
I think actually, yeah. So actually, as you said, right?
The issue
what
with that is you have to keep track. The issue with that is that you have to, you either have to keep track of what items to delete from the set, or you need to, when you check for a duplicate, instead of checking just if it's in the set, you need to check if the last recorded position for it is past where your end pointer is. That way you'll know if that element is actually in the range that you're considering. And then if you do it that way, then when you try to record the max result, you're not really looking at the size of the set. You're just looking at the distance between the 2 pointers, or something like that. Instead,
right. Yeah.
I'd have to like try to implement it, but you know.
Yeah, I tried that approach like super long back. Yeah. But I have this in my top of my mind, so I had to return this. But yes, I did try that approach, like directly going back to that index, because instead of set, you will just use a hash map, right? Where you put the character and then the index of it, right? So which is like A comma 0, and then you have B comma 1, C comma 2, and then you have, oh, now B exists, which means until here I can move maybe my begin pointer until like this index, right? So or maybe index plus 1, this index plus 1, which is 2.
That's what I meant. Yeah,
I'm sure,
you
yes.
take that index
Yeah.
plus 1. The thing is, you'd have to, instead of worrying about removing items from the set, when you check that the character is in the set, you would just check if the corresponding, like the last recorded index is
Yes.
after where your begin pointer is sitting.
Exactly. Right.
Because
right.
if
So once we
because otherwise it's
I see
too
what you're
hard
saying.
to
Exactly, to remove things from there, right? Yes.
yeah.
Yeah, that's a good one. Yes, I think we can actually do that. I don't know if we have enough time to code that.
Just for the interest of time, I don't want to go too deep into like different variations, but does anyone have any questions like on this like approach that we have up here?
Yeah, I think in both the cases, the time complexity is still O of n, right? Even if you use the
Yes.
indexing.
Yes.
Yeah. Yes.
Yeah. So right. So like, if we think back to the worst case for a second, right? So like, what would the worst case complexity be, where we look at every substring?
Yeah.
All
You mean to say in the brute
What do you consider worse? Like
the
when
brute-
you have a string of it's the same character repeating all throughout?
Yeah.
No, so like a
all
brute,
duplicate characters.
yeah, like just a brute force approach where you like consider every substring, then like you only look at the ones that have unique characters, and then you take the longest one.
brute force would be O of n cube, I would say.
I mean, that would be huge. What basically you're taking like every string size 1, every string size 2, etc. And checking for
So you have
that.
n.
That would take forever.
Well, not forever, right? Like you have n strings
Well,
of size 1, and then like n minus 1 of length n minus 1, right? Or sorry, of length 2. So you have that series. It's like n plus n minus 1 dot 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 plus 1. So that would be O of n squared number of substrings.
And then compare those.
but it's not just a number of substrings. It's that you're cycling through. You're repeatedly cycling through things that you've seen before. So it's not very efficient. Like you're.
Well, of course. So
you're
like
checking. Yeah.
So yeah. So I'm like the point of this is I'm trying to like see what we gain from using the sliding window technique versus the brute force. So the sliding window technique gives us an order of n, like an order of n way of solving this. So what is the brute force? We have O of n squared substrings, and then.
But then it's n for each string. You have to go through the whole length, the whole string to check it.
Yeah.
Or at most the whole string to check it.
Yeah. Yeah. So the n squared.
Actually, I guess it's n cubed.
Sorry.
I guess it's n cubed then.
I'm thinking exponential. We can make it exponential also.
I don't think it would be exponential. So like, if you have those n
How
squared.
about if we can?
I think it's n squared.
It's there's n squared number of strings, but then you have to cycle through all of them. Doesn't that count as an extra times n?
You have to cycle through them to get to know the duplicates, right? So you have to.
Yes, so you have n squared strings, and then it's order of n to check. So yes, you're at n cubed. Yeah. So just yeah, I'm not trying to make a big point. I'm just saying like the technique that we're using.
This is good. We need to be able to compare methods and be able to say what's the difference between them. So this is good.
Right.
I
Okay.
think one we can make it become n square if we because we know when we slide to the next substring, right? We know the beginning character what they're gonna be. Then when we walk through the substring, we will track, okay, what is the last character that in that substring that match the begin character.
Yeah, I mean, of course,
can be
like,
tuned a little bit to make
right.
it
So
become-
the point is like it's like the worst case will be like n cubed, and then I don't think there's a better way of solving it than like O of n time complexity, and then I'm sure you can have like things in between that spectrum.
I'm not sure it's n cubed. I mean, in the interest of time, we may not want to discuss it, but then just a quick example, if you're looking at A, B, C, D, right? So the brute force would be you look at A, then B, then C, then D, then you look at A, B, and then you look at B, C. You're looking at B twice, then C, D, you're looking at C twice. Then when you do A, B, C, you'll be looking at A, B, C once, then you'll do B, C, D. So when you look at B again, so you're doing B twice. So I think each character becomes twice at least, depending upon the length that you're looking at, right? So I don't know.
No, Supriya, what? So instead of A, B, C, D, what if we take the string that is 20 in the length?
Okay.
So basically, all substring is n squared. That is for sure, right? Now, you can't be very precise saying that how many times, because that analysis will be too complex. There are a lot of things in this particular problem will come in, right? Where you have only 26 character or maximum 256 character, something like that. So your string length is not gonna go more than 256. But overall, coming up to the conclusion saying that I can look each character twice, that is a little bit dangerous, because the moment you take the bigger string, it will be more.
Yeah.
Yeah, for these kinds of problems, I usually ask myself, I say, okay, the example they gave me has an input of size 5 or whatever, but then I just ask myself in my head, okay, imagine input is size 10 versus size 1,000 versus size million. Like I just go up in order or whatever to force myself to think about, okay, what can I generalize?
Okay, so I'm just going to move on to the next one, just in the interest of time. So again, let's just take like a minute or so to read and think about this one, and then we'll discuss. Okay, so just to back up for a second, so like the theme of this session is strings, but like as I was studying string problems, I was finding that there's like not like any like one particular technique that applies to strings over and over. It's kind of like all of the general problem solving techniques that we see over and over apply to strings. So like in the choice of problems that I picked today, I tried to pick like from a wide range of different problem solving techniques that we see throughout the sessions week over week. So the first one was a sliding window, like a pretty classic sliding window problem. For this second one, is there any like technique that comes to mind?
Yeah, backtracking.
Backtracking.
I would, I'll let someone else go. It's okay.
Yeah,
I'm
so
thinking backtracking, but with a little clause, because the closed bracket has to come before the open bracket. I think with that clause we can use the backtracking approach.
right, exactly. So yeah, backtracking is like the answer I was looking for.
What's meant by backtracking?
Yeah, so just to like keep this as a self-contained session, I'll like kind of give a brief overview of like all of these techniques. But again, so all of these techniques that we're going to discuss today, we often have like entire sessions on just sliding window or just backtracking. So let's just do a brief summary of backtracking. So the idea with backtracking is at every you make a decision and then you explore the consequences of that decision exhaustively, and then you sort of backtrack to that decision point, and then you see the consequences of making the other decision. So in this problem, you're trying to generate all of the strings of valid opening and closing parentheses. So at any given point in time, like you have like some number n, let's say n equals 3. That'll be like the number of opening closing matches that we have. So at any given point, you have a decision of whether to put down an opening or a closing bracket, with the restriction that you can never have a valid string if you have more closing braces than opening. So like in the first step, you can't have just a closing bracket by itself. So you have to pick an opening, right? But now, so think of this as like a tree. It'd be better if I had like some sort of a whiteboard, but we'll just go with this. So
you can actually use the Zoom whiteboard itself.
Oh, Zoom has a whiteboard?
Yeah, just stop the sharing, and when you click share, there should be an option called whiteboard there. You can actually do that. Yeah, click share again, and then you should see whiteboard.
Okay, cool. Okay, so can people see this whiteboard?
Yes.
Yeah.
Okay, right. So backtracking, you like in all the backtracking algorithms that you end up generating a tree, not necessarily a binary tree, but in this case, it just so happens to be a binary tree because you can only make 2 decisions, like either put down an opening or closing bracket. But so the root of the tree will always be an opening brace. And then after that, you can either put down a second opening brace or a closing brace. Then if you take the left subtree, again, you can either open. So you have 3 openings. Or if you go this route, you can have open, open, close. So this subtree, like the only valid string here will be open, 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 close, close, close. So I won't draw that full subtree. Here again, you can either open or close. So you can have like open, open, close, open, or open, open, close, close. And so you see the pattern basically. And so just imagine like the fully fleshed out tree that this forms. What a backtracking algorithm does is it's essentially like a depth first search on this tree. So you explore the first one, depending on how you implement it, like it'll go all the way down this subtree. And then when you reach a leaf node, which will be when you run out of parentheses to put down, you can put this in like some output variable, like a list or something. And then since it's recursive and it's the depth first search, that backtracking part will sort of take care of itself. You don't have to write it Because if you think about depth first search, right? Depth first search is itself a backtracking algorithm, because if you just think about a general depth first search on a graph, all right, so what is a depth first search? A depth first search is where, let's say we start at this node, then we take some neighbor, and then we look at like one of the neighbors of that neighbor, and we basically go as deep as we can into the graph. And then like by the magic of recursion, like the recursive stack will be popped back until our last decision point, which would be here. So then you would explore this subgraph, and then it would pop back to here. Yeah, does someone have a question?
Yeah, that's nothing but a backtracking. Yeah, you're right.
Exactly. So that's my point. So like DFS is like a backtracking algorithm, and you can also think of backtracking problems as doing a depth first search on this problem space tree. So that's like a brief overview of backtracking. We've had like full sessions on backtracking. There's a lot of other like classic backtracking problems. This is one of them. Another one would be like if you're given a telephone keypad, like I guess usually it's like 2 has like A, B, C, and then like 3 might have like whatever, D, E, F. So you have like different characters associated with every number. And then if you're given some number, like let's say 2, 3, 4, a classic backtracking problem would be to say like, okay, enumerate all of the different like letter mnemonics of that given number, right? Like for 2, you could have a choice of A, B, or C. So like your tree would have A, B, and C. Then the next number is 3, so 3 can be D, E, or F. So you'd have like 3 branches there. Same thing with this branch, and so on. So that's a case where it's like not a binary tree. And then another one is like the n queens problem from chess. So there's a number of problems in this category, which can all be solved with backtracking. So does anyone want to give this one a shot and write a solution for this? Anyone going once, twice? Okay, I'll just share my.
I mean, I did this problem, but if someone could, at least try.
Was that a seam?
Yeah.
A seam? Yeah, please. Do you want to share your screen?
Sure. Please let me know when you can see my screen. Computer's a little slow. Give me a second. Can you see my screen?
Yeah.
But for some reason, the font is so small, Theme.
Yeah, you could try like, you see that little, yeah.
Mm-hmm.
Is it better?
Yeah, there you go.
Yeah, now it's better. Yeah.
So we'll go with the same approach with the DFS. And so for DFS, I would create some helper method. So basically like Hanif.
Sorry, I don't see the full screen. I only see like half of the right side. Can you scroll to the left?
I think I can see the full screen.
Is it?
Yeah,
Yeah, me as well.
Yeah, it might be a problem on your end.
Okay.
Yeah, I also can see 2 screens.
See if you have zoomed in into your screen, because you can actually zoom into your screen, then it will separate.
Oh,
Yeah. I mean the recipient also who is watching, they can zoom.
Okay.
So that might have happened. Okay.
we can see you, Bhavish. So here we have we'll have opening, and then we'll have count of closing. So this is like when I'll start, I will have something like a count to get started, and this would be what is the total length I want, and then especially a problem with string builders. Sorry, with the especially the problem with backtracking, we have something to add then remove. So I would be using a string builder, and then I also want something for my result.
I actually cannot see what you're typing. Interestingly, I can see your screen. Is anyone else having that same issue?
I'm seeing the already code that is already typed.
Yeah,
So
yeah, I see.
Yeah.
I
so
see
I
your full.
highlighted something. Can you see that?
Exactly.
We can't see your mouse. We can't see.
I think you might be
Static
having two screens. I think you might be having two screens and sharing the wrong one, maybe.
Yeah.
Let's try again. Can you see now?
Yes.
Yes. Now it is an empty.
Okay, so let's get started again. So what I was trying to say was I would be doing a helper method. Can you see that now?
Yeah.
Include. So I would be having int closing. Then what else I need? So basically I need something like how so this would be coming from here, right? And then
String builder.
Then I want something like a string builder. So we can use string builder, or we can't do without string builder. And then okay, then we want something like a result. This is standard any backtracking problem which only has something similar traits. And when I have to call it, I would be having something like a string. Result.
Just to make sure your first two parameters there in your helper function, opening, closing is the number of opening and closing parentheses you have left.
No,
Okay.
it would be, it depends how we want to interpret it. We can interpret it like reduce it, or we can send it from 0. It's all
Either way.
Either way.
Yeah.
It's up to us how we want to take that. And so if I have to call this, I can start with n, or I can start with like 0. It depends on us if we want to decrement it or increment it.
Yep.
So either way. Just pass the new string builder, and then say this int egg9, what I want to return is the result. So for now, any questions till now?
So what are you planning to use this? How are you planning to use this first 3 parameters?
Yes. So so like Hanif mentioned, first we'll start with this one single one, and after that, what I can do, I can add 2, or I can go like this. Correct? And this way I will keep on going down.
So the parameters in like a recursive solution like this, they keep track of like the state that that you're in. So like, so for example, you could be somewhere in like the tree where you've used like, let's say like 2 opening and 1 closing. So you want to keep track of that state as a parameter.
So initially, what is my state? My opening is 0, my closing is 0, correct? So as soon as I'll reach here, my opening will become 1 and my closing is still 0. And at this state here, if you see both opening and closing would be 1, 1. And the other state would be, this would become 2 and this is become 0. But I want to, and then I also want somewhere my exit condition. Let's say my n was 1. So at this point, I should stop. I should not go even further down. Let's say my n was 2, but my openings become 2, but my closing is still 0. So I want to go further down till this guy becomes 2, 1, and under that there is another state 2, 2. So that means I have now, so this is my exit condition where I want to stop.
Right.
And there would be,
I would like to add, sorry, Sai here. I would like to add whatever you are saying. So here, when input n is equal to 3, we are trying to represent opening and closing as an integer here, because we want to use 3 open brackets and 3 closed brackets.
Yes.
So that's why we have opening and close as 3 and 3. And when you form a string of length 6, right? Because if you see the output of the given example, the length is 6. So when you have a length of 6, you have to record that as a result. And you will increase your opening, you will decrease your opening. So you're playing with these 2 pointers, like, okay, do open plus 1 or close plus 1 or open minus 1, close minus 1. So you do kind of a backtracking, and then you try to append the open brackets to the string builder or close brackets to the string builder, append to the result, and then return back the result. I think, yeah.
Is that clear, or shall I explain more?
Yeah, I think it's clear.
I think that makes sense. Yeah. Thank you.
I think when we'll see the code, it will become a little bit more clear, but we can again come back and discuss and clarify the doubts. So my one condition would be when my opening is less than n, so basically I want to go start adding my opening, and then, so what I want to append is a starting bracket. And then I want to call my helper with, so now so my opening should increase by 1 now. I already used it. Like, this is this state where I am right now. And then closing is still remains same. And then I would be sending the string builder, and then doing this. But if I'm done with this path, I also want to backtrack. So once I'm done with this path, it is like this. Sorry, I want to remove this guy. Or the other way of doing it is because it's, now when should I do the closing thing?
Yeah, that will be the same thing, right? So when closing is less than n, you'll do the same thing, but
when
you do
closing is
1.
less than opening, then only I can do that.
Yeah.
If you see the tree.
Oh, I see.
So the opening should be less than, closing should be less than opening. So closing cannot come if you have, if it is equal to the opening.
Right.
There should be extra opening, then only closing can play in. Rest, everything would be same. And even I think we don't need this condition. We'll come back to that.
Okay. I know you're still changing the code, but I'm looking at line 19, and You're counting how many have been used?
Yes. So I'm counting if closing is less than opening, then only I can close something. Otherwise, I can't close.
Right. Because it has to be a valid bracket, right? So you can't have like opening bracket first and then a closing bracket next. So it has to be a valid bracket. So whatever the examples they gave here, it should be a valid parenthesis. So that is the reason this is the clause saying that closing is less than opening.
Mm-hmm.
Or I mean, I can actually I mean, the way I did is for the line number 19, you could put closing is less than n. But on the line number 12, I will add one more condition saying that that here if it is less than this, then you revert it back. So we can also do that way, right?
Yes, we can do that way also. But
Right.
my
Yeah,
exit.
but this is kind of cleaner.
But let's come to our exit condition. What would be exit condition? Where I will say like, okay, now I'm done.
Equals n, closing equals n.
So if
it should be less than n, right?
If opening is equal to n, and closing is equal to n, so that means this is my exit condition where I have reached my state, the final state, with one path. There could be multiple paths, but this is one path which I could have achieved.
Or a leaf node in the tree.
Right.
Yeah, leaf node at the tree. That's a good way.
Like someone mentioned, like, if we can check if the string builder length equals 6,
yeah,
then we know that we know that we satisfy the condition, right?
There's multiple ways you can like check for the ending condition.
We can do this. We can even do this, like checking the string builder length is equal to 2 into n. So yes, either way we can do that.
What I mean is the condition by the time we reach there, we guarantee that even if like the string builder, the length equals 6, there would be no case that opening is different than closing.
Yes, yeah, we agree to that.
There's no advantage of doing it that way. Like you could do it either way, right?
No, I'm saying that because if I check the string builder length equals 6, what if there's a case that the number of opening is different than number of closing?
No, because we are controlling it here. So if you see, we are controlling it here. We only open something if it is less than n. And
yes, so the number of opening could be greater than number of closing, and the string length still equals 6.
No, but that's not possible, right? Because
I think he's saying if we check the string builder that way, like you might that might be a possibility. Like you could have like 6 opening.
How there would be 6 openings, because at line 18 we control that.
Or 5 or whatever. Like you could have some like invalid state like that, but that's why we're not using the string builder, right? Like that's why we're checking opening equals exactly n and closing equals n. If I understood what you're saying.
I think this is a question, right?
Yeah.
So
I think this is actually wrong. Like I think this can lead to invalid.
But how? But because at line 18 we're controlling that.
So the only thing you're checking on line 18 is that it's less than n, but like you could have 5, for example, like 5 opening, and then there's no like valid way of putting, because you can only put 1 closing, right? So like you could have like 5 opening and 1 closing.
So let's say my n is equal to what, 5?
Sure. Yeah.
So I think one thing I want to say is that when n is equal to 5, that means we have a 5 opening and 5 closing, right? Pair of 5. Now, anytime basically I can, if I want to start, right? I want to put a one bracket. I have only 2 choice at any point. Either I can use opening bracket or close bracket, right? And that is what we are doing in both of if condition. And
in this case, we always preference the opening, right? So opening always going first. We don't have like take either opening or closing.
Yeah, this
going here
looks like
opening always.
So that's correct. We basically first open everything and then close everything. But then when that path is done, right, the if path, we come to the second if path also. Is that correct?
Yes.
And so at that time we can start doing the one opening, one closing also, right? Or do you think that it is never going to happen?
Yeah, actually, I forgot that.
No,
Forgot that
we
it's
will
N, not
end
two.
up doing one opening, one closing at one point. So first, I think will be like 5 open.
That's so. Yeah. So
Yeah,
I mean,
so he's just trying to go in a certain order to generate these in a specific order with it, where the priority is to generate the versions that have the most openings first.
it doesn't matter. I mean,
I know it doesn't matter.
order,
I'm just saying. I'm trying to explain what the approach is.
But anyway, let's just stick with opening and closing equals N. I mean, there's no.
Yeah, maybe we can go with the one example, and maybe Asim, you can draw the tree. In a sense, where all we are going, and yeah, that could be maybe image also. So that will, with the bracket image in a sense.
Okay.
Yeah, so that will be very helpful to understand with whatever number we want to run. I think the N is 3 is good because there are not many options.
Okay, so what should be the N?
Just do like
3.
Yeah,
3 is fine, right?
Hey, quick question. Sorry, Sai here. So I just tried when string builder.length is equal to 2 times n. So that's also working fine, but it's taking more runtime. That's it.
Yeah, that's yeah. I mean, if you want to like draw it out, go ahead. But there's no advantage of checking like.
I think they are both same.
Yeah, exactly.
So I don't think we should spend that much time there.
Yeah, I kind of agree. Yeah,
and because we have 2 more questions on our plate.
Yeah.
But here the main concept is like we are discussing things, get idea, and it's always good to try back home.
Yeah.
I understand it, but like, we somehow have to prove that, okay, why that case not happen? Can you show me the line of code that case wouldn't happen?
What case wouldn't happen?
The number of opening is greater than the number of closing.
I actually think it's better to talk about a condition where you're forced to use the opening parenthesis and not the closing one.
Yeah. So I ran this.
Like,
this is working.
What you really want is something like, if the number of closing and opening is the same, then you have to use an open one.
Yes.
Yes, because closing has to be less than open.
So maybe put that in maybe add that to line 18 or something. You could like
why do we need that condition?
This everything that's on the screen right now is sufficient to solve the problem.
Yeah,
because see, when
it's sufficient, but the idea is to also present something that's extremely clear.
Yeah, just because it accepts and you pass the test, but we not be able to see the clear picture.
Right.
Why?
So
okay. Yeah. Maybe I guess
I got your point.
Can you quickly go through? And yes, please go ahead.
Okay. So
Vivek, you were trying to say something.
So this is our. So initially, I can't start with. So initially, both of them are 0, 0, correct? I can't start with the closing. So this condition safeguards that. I can't put a closing if it is initially both are 0, 0. I can't put a closing, but yes, I can put an opening, which is less than n, correct?
Yes.
And after that, now I can go to another state where I have put this opening. From this, now where I can go? I can put one more opening, correct? Because this is still less than n. We are still here, correct?
Yep.
And I can also put a closing here.
But yeah, I mean, if you go code wise, we'll basically keep going in one direction.
Yes. So
Okay,
from
so
here,
let's go that way. Yeah, yeah.
Yeah, until opening is greater than or equal to n.
Yes. So here I can again put one more opening, correct?
Yep.
Can I make a recommendation?
Yeah.
I think if you're gonna walk through a problem, what you want to do is have a small chart in the corner of your screen somewhere where you're tracking, your different variable names. So n, closing, opening, and you can just put another column next to that column that tracks what those numbers are. Because if you're gonna walk through your code and show someone that it works, right now you're just drawing a tree, with all of the different spell outs. But what we really care about is you want to, on each pass,
Yeah, I
we're
can go to
actually
each one.
checking
So-
some numbers, right? So
Kind of like a stack. Maybe we can draw the stack every time we are going down the recursion.
So Asim, do you want to just draw like the number of closing and opening for every like node in the tree that you're drawing? Like you could just have it like opening comma closing, like so. It'd be like 1, 0, 2, 0, 3, 0.
So here we have 1, 0, right?
Yeah.
Here we have
2, 0.
2, 0, and here I have 3, 0. From here I can't go and put an opening thing. Right now my string build. Okay, so do you also want me to put string builder length, or can you assume it by looking at both the numbers? Or looking, at least visualize it. Can you visualize the string builder is 2, or shall I write 2 also?
No, that's
I think that's fine. Yeah.
Okay, thank you.
Hey, actually, one more recommendation. Sorry, instead of taking n is equal to 3, right? Just 2 for n is equal to 2. It will be very easy.
No, it's okay. No,
I mean, we can't like keep like redrawing this, right? Like let's just stick with this example.
Yeah.
Okay, so here, if you see, I can't go and put an opening thing, right? So I have to go towards closing now.
And the reason you can't put opening is maybe you can show the code. Yes, quickly.
Yes, so this is done. I can't go further in this, but yes, I can still go with closing. Because my closing is still 0 and opening is 3. So here, what I will do is I will put one closing. And right now my state is 3, 1. Again, I will go inside this loop. And again, this will not execute, this will execute. And so here I will put one more, like, and this is 3, 2. And then what will happen? Again, I'll go one level down. I'll put this, and this, and this has become 3, 3. And right now, if you see, we have reached this position where my string builder length is equal to 6. So I can take this as my answer. Is that correct?
Yep.
Okay, so basically I reached at this point, and now it's time to backtrack. Where's my rubber? So basically I will go back from here. I will remove this guy. Basically I'm done with this. I will go back here. I'm done with this path also. I will go back here. I'm done with this path also. I will go back here. I'm done with this path also.
Can you switch back to your code for a moment?
So you won't be able to visualize the backtrack here because I'm still going back, where I couldn't go further.
Actually, we can visualize the backtracking.
I want to actually see. So presumably this is line 21 and line 27.
Basically, I can't go inside further. I can't go here. I can't go here. So I'm keep on going back. So I'm keep on removing things from here as soon as I'm going back.
Can I show how we can visualize it? I think it's gonna work. I think it's gonna work better instead of the tree. I mean,
Sure.
I don't know. Hopefully, let me show.
Okay, you want to share your screen?
Yeah.
Or you want me to first complete this thing?
Okay. Yeah, complete it, and then I mean, if we have time, it's okay.
Sure. Thank you.
Is your idea to draw a stack?
Yeah. Yeah. Stack.
Yeah, if we write the function, let's say that helper with this parameter call helper of this parameter call helper, and that will help you to visualize.
Yeah, I mean, we could just like draw like a stack beside this or something to seem like maybe like Notepad or something. I don't know.
Yeah,
Okay.
let's. If this is not helping, then we can stop. If it is helping, then we can continue doing this.
Yeah,
Or-
it's helping. Yeah, I can see it.
Shall I start with the stack? Or
Just like whatever you just did so far, just like draw the equivalent thing in a stack, like the recursive.
Okay. So we'll do it here. So how we started was helper 0, 0, and let's say my string. So this was my string builder, which was empty, and then we were having this 3, and then here we have this result thing.
Yep.
From here, where we went, I'll keep on copying this. So actually, good. I'm getting a lot of good suggestions. Thank you, folks.
Yeah, now you can write and put a tab so that.
So from here, I went this state.
You can assume you can write down also. That also is okay if you don't want to go up, basically.
Oh, visually, I always do things that goes up, so I can go down. That's fine.
Yeah, I mean, visually it will help.
Yeah.
So helper
Yeah.
call helper, basically. Yeah.
Okay.
And then one tab inside so that we know that it is.
I visualize it the same from bottom to up.
Oh, is it? Okay.
Doesn't matter.
Yeah, but this way, like it kind of looks like a tree also. So.
I think
Yeah.
even any Visual Studio or other things also shows like going
I
up.
see. Okay. Yeah.
So at this point, I'm at state 1. So basically, I reached here. It's time to add a bracket and go for one further down. From here, here again, I can add one more, which is 2, and which is this. So, and from here, I can go till 3.
Yeah, just delete the closing, I think, in the previous one.
I think when I add it, always put a
Oh,
close.
yeah. Yeah, it's automatic. Yeah.
Yeah. So now at this point, I can't add one more bracket, but I can go towards closing bracket.
Yeah.
So this would be 1, 1. This would become this.
I'm
And-
sorry to interrupt. In the line 33, just the closing bracket, I think it's gonna confuse.
Yeah.
Okay.
Thanks.
So now we are so till now we were going in the first if condition. Now when we are
good.
putting the closing condition, we are going in the second if condition because first one is not valid.
Yes. Because it already reached 3.
Yeah.
So this is also 3, and this. So here now this will go to the first condition, which is this. It's time to transfer the result in this guy.
Just a question. For line 35, do we have to indent or it should be the same indentation as 34?
Like every function, every like recursive like function call is another
function. Yeah, it's not exactly going in one level more depth.
Yeah, so it's like this is like illustrating the depth first nature of it.
Okay.
So,
Okay, so let me. You're if we look at on line 18. You're saying I have enough okay. Ugh, go back there. All right. So I see on line 20 how you call the next layer down.
Line 20. Yeah.
Right. And so all of these lines 31 through 37 are really all inside line 20. That's all the first pass.
Yes,
right?
exactly. Yep.
Yes.
Yeah.
Okay. And then after this, we are we are just reducing the length by 1.
Mm-hmm. No, right now we just put our answer in our result.
So you like for a backtracking problem, right?
So-
Like make a decision. Like on line 19, you're making this decision to put down an opening bracket, and since he's reusing the same string builder, you have to like undo the consequence of that decision. So you just remove that same thing that you put down on line 21.
Okay, so if we look at, okay, so this 37 is equivalent to eventually the result you would get somewhere on on that last call. It's equivalent to the result you would get from line 26. Is that right?
Equivalent to yes. So from line 26, yes.
Okay.
You start entering the branch in line 26 on the call
Line
on
36?
line, I think it's 35, right? Like as soon as you start putting down close.
35, yeah, 35, 36, and 37 are basically repeated.
Yeah,
You repeatedly end up in that loop, in that that piece of code at line 24. Fine, but then what I'm trying to understand is when does line 27 happen?
I mean, 27 starts happening.
We
as soon
haven't
as-
reached till 27 yet.
Maybe we need to create a next slide. It's like 39. The slide 39 is the one actually we add it into the result and we return it back.
Yes, correct.
So sorry, I think line 37 should have that highlighted portion should still be empty.
That's correct. I mean, the next call will add it. So yes.
Okay. So
yeah, I mean, we just take a shortcut, but yes, and then that call.
Yeah.
Now that call
So the
basically
next call
edit and
is
don't
not
do
going
anything.
to be.
Yeah. Yeah, it
He's
doesn't
not
do
going to
anything. But
call helper.
now in this call, yes, we add the result, and then when it goes back, we keep removing. So we are going back, yes.
I don't think this is a great way to represent this. I'm sorry. 38.
How can you have
Line
helper?
38 is.
How can you
You're
have
not calling helper.
Yeah, I mean, when you call help, sorry, Annette, I think I interrupted you. I was just wondering.
Could you scroll up to line 13, please, so that we can see it?
Yeah, we are not calling helper.
No, but he's actually adding in the result, which is in the helper parameter, right?
So go down, yes. So
Correct,
if you
what
go
you
down, right? If you go down, so when the helper 33 on the line 38, it calls, inside that we basically add into the result. So when it returns, it will have a result. So can we remove the line 39 and copy the line 37 and put it there?
Wait, why?
Basically now we are returning, right? So that time we will have that result.
I haven't not yet started returning, so I'm still. If people
Yeah,
are this approach, then I'll start returning. Otherwise, I'll keep on hold till there are more questions.
Basically, the point is you cannot have two helpers with the same 333, right? The values would have changed. So that is not possible.
So the adding is happening. It is not. So when we call helper 323, call helper 333. That is fine. But when we within helper, when we reach helper 333,
yes,
basically in that case we are not calling further helper, but we are doing this addition.
Addition.
And we have to represent it somehow.
That should be result.add. That should be on line 38.
Yeah, so we have to represent it somewhere. So rather than calling helper 333, we can say the result.add here. Yes.
No, actually it is calling helper 333. It's actually going 333.
Yeah, that is on line 37
Yeah,
itself, right?
you enter the helper function with 333 and the full string, and then you add it, and then like there's no further call to helper after that. You pop
Right.
back
So
to the
line 38 should be result.add.
You can write it in
like
front
that.
of line 37, like after the semicolon, you can say result.add or something so that you know that that function has returned the result.
Or
Like
we can
after
have the array with the added. brackets instead of calling a function.
Basically, line 38 should not be there. You're
Right.
not making a second call like that.
See, that's what I did earlier.
Yeah, that is what he had earlier. That's why he just added it straight to the thing. Like we
Yeah,
can't.
that's what
There's no way to like perfectly represent like this.
Yeah,
one.
yes, exactly.
Yeah,
I mean,
that's what I
either
did
you can
earlier.
I wouldn't put it in there. When you do that, you're suggesting to the interviewer
Yeah, that you are sending that input.
this is an argument you're passing in.
Right.
Right. So you can basically write instead of helper, you can say that add into the list. Next line.
Okay.
Or you
Yeah,
can put
yeah. Here you can say
put
that.
commented
Yeah.
code right behind it.
Yeah.
Either
you
way.
can say that. Yes, add to result or whatever. Yes. Yeah.
Awesome.
And then show
Okay.
what the list looks like at that point.
Yeah. Makes sense. Perfect.
Okay.
Yeah, I think to visualize backtracking all at once, it will be kind of difficult unless we put that into a paper, like pen and paper, right?
Okay, so shall we move further? Any?
Yes, please.
Okay, so now it's time to, I'll keep this in separate place because I will be using this a couple of times. So now it's time to backtrack and we'll go back. Now we are at line 27. It's time to remove a guy. And then after that, it will again, we are done with this. It will go back, it will remove this at again line 27. And again, it is done with that. It will remove, okay, I should be doing this at one step. So we have removed this. So this guy is done. And we again remove this. Again, this is done. And we again remove this. This is done. And we are here. So we are done with all that iteration. So now I can remove one more. Not here. So I can remove this and done with
Okay, what
this.
line of code are we? Hang on. What line of code are we on this? On line
So
34?
line 21.
21. Okay.
And
yeah, so for people who are like having trouble, like I guess it could be kind of hard to visualize the like recursive functions at times. So like what I would recommend is like take this code, for example, and then
I see on line 21. Yeah, and then after that you're gonna go to line 24, right? And then you add the
yes.
So if you step through this with a debugger, I think this will like make a lot of sense. Like
So
you could
now we are here, and now I will just do one more step. I think then we should proceed further. So this step, I can add one more bracket and put a closing one and go further. And the next step, if we go further, it would be, I can put a opening.
Can you explicitly state how you get to the point where you add the closing bracket, even though you could have added the opening one?
We already explored that possibility, right? Like
what line is that?
We're already past line that branch from 18 to
21.
22.
Yeah, we are at 20. Yeah.
So this, okay. You got to a point where you ended up on line 21, right?
Yep.
That reflects.
You finish 21 and you go to the if condition after that. The closing is still less than opening.
Mm-hmm.
So the closing was, I think, 0,
okay.
and opening was 2. So you do 0, 2. So sb.append will add the closing bracket, at which you will get a 1. So it'll be 2 and 1. And then again, it'll go back. And then
it will open again.
So
Yeah.
this.
no,
So this
What
is
will-
at
it will
line
return to the SB dot set
26.
line. Okay, go ahead. Sorry.
And here we again did at line 20.
Yes, it will open again. Correct.
Yeah, it will open.
And then I can't go because this is again 3. I can't go further. So I'll do line 26 only.
Is the input on line 35 correct?
No.
Should be a close there. A closing.
Okay, thank you.
No. Oh, okay. Yeah.
Just put a closing here.
Yeah.
Yes. And then we'll go one more level down where I'll put this 3 and this would be 3 and this would be like this. And then it's time to add a result here, which would be this. Yeah.
Okay. I think like let's just cut this here. I think that was like a great explanation. Thank you.
Yeah, it was really good feedback. Thank you all.
Yeah. So if anyone's still like unclear about this, I would really recommend just like taking either this problem or like any other recursive problem and just like stepping through with the debugger, and then you can like actually see the function stack at each step and see how it'll pop back to like the previous decision point.
Are we going to get this recording?
Yes, this is actually being live streamed on YouTube, and I'm assuming it's going to be like automatically uploaded once the stream is over.
Okay.
Yeah.
Cool. So let's move on to the next one. All right. Okay, can everyone see my screen?
Yes.
Yeah. So let's just take a couple minutes. I'll be right back, and then we'll start discussing this one.
No, I think nobody's speaking.
I think
No, I
they're
think
just
he
giving
said
us
he
time
has to
to
rejoin.
review the question.
He said he has to rejoin.
All right, so does anyone want to take like what's the technique that comes to mind for this third one?
DFS.
DFS, okay. Any other ideas?
No, breadth of search.
So were you saying breadth or depth first search? Say.
I was saying breadth first search.
I think I heard both breadth and depth.
Yeah, I mean, myself, I'm saying BFS, B for breadth first search.
Breadth first. Oh, okay, cool. So I think both of you guys are saying breadth first search. So yeah, so this is a breadth first search. So why breadth first search for this one?
So if you see, we are changing the state.
So, right, because we have to find the shortest transformations, right?
Exactly.
So from the begin word to the end word. So the earliest that I can reach my end word, that will be my the shortest transformation. So, but this will be a little different type. I mean, simple, straightforward BFS, but a little more the logic that you have to write on the top of it. So they said when you go from word to word, you can change only one character at a time. So if we take the first example, so we have a begin word and the end word. End word is, so you have to go from hit to cog by changing only one character at a time. And when you change that character, it has to be exist in the word list, which means I can, so for hit, I can change the first letter. So they said all lowercase characters, which means I can change from A, B, C, D until Z, right? So H, I can change to A or B or C or D, and then I have to check if that exists in the word list. And then I go to the next character, I, and then change A, B, C, D, and so on. And then I check in the word list. So, and then you have to add everything to the your queue, your BFF, and then you pick, whenever you find the end word, then that will be the answer, like the length, right? So yeah.
Yep. Yeah, exactly. So, right. So the keyword that like makes breadth first search come to mind is it's asking for the length of the shortest transformation. So if just in general for like any kind of graph search, if a shortest path exists between two nodes, then the breadth first search will get you that shortest path. I guess I can just illustrate breadth first search real quick on the whiteboard again. So, okay, let me clear this. Right, so
you can actually click on the next board. It will open a new page in the whiteboard itself. So on the right bottom corner, there will be an arrow that you can press.
Oh, this one. Yeah, I'll do that next time. I already cleared out the previous stuff. So like,
you can still see the old screen.
Yeah, so this, oh, you could still see it?
Yeah.
Oh, okay. I guess it only cleared it for me. So it's a new one now, right?
No.
No, I still see
I
the old
think
one.
Yeah, we can still see the old one. Yes.
Maybe you're on different screen window.
It's being cleared for me. I don't know why you guys are still seeing it. Is it cleared now? Like, are you seeing what I'm drawing?
No.
Empty.
Maybe you can stop sharing and then redo it again.
Oh, hang on. This is paused. Okay, sorry. So now can you see it?
Yes.
Yes.
Yeah.
Okay. Right. So this is like really kind of like a graph problem in disguise. Basically, like you could think of every word as a node in the graph. So like, let's say this is your starting word, like hit. Right. And then, so hit will have like a number of adjacent nodes. I'm not drawing this exactly, so let's just, like in the interest of time, but like hit will map to hot because you can get there with just changing one character. So you think of this as hot, and I don't know, depending on what we have in the dictionary, like it might have some other neighbors too. So eventually, like there'll be some path that will get you to the end word that you want, which is cog in this case. And so like you could, if you did a depth first search, the problem is there's no guarantee that the path that you took, like if you find some path from hit to cog, there could be multiple different ways from like to reach the end here, but there's no guarantee in general that like if you do a depth first search that you're going to get lucky and find that shortest path. So a breadth first search, instead of searching like as deep as you can, you search level by level. So you would like look at all of Hit's neighbors, and then you would add all of those to a queue, and then you would essentially start a breadth first search from each of those, right? And then that sequence is guaranteed to give you a shortest path once you reach the end, once you reach cog.
So Hanif, to get to the hot, first will you like replace the H with all space? I think I missed that part. A, B, C, D. You'll.
Sorry, yeah, let me bring it back. So yeah, can you repeat the question?
So I was just wondering. So before going to hot, how will you first look at the first character, that is H, try to replace it with other characters and look if it is available in the dictionary, and then
Yeah.
go to the next character? Is that what was explained? I think I missed that. Yeah.
Right. So like,
okay.
Basically, I mean, you could implement it like a couple of different ways. Basically, like you just want the neighbors to be the words that are in the dictionary that are like one letter away or like one transformation away.
Right. One character away. Yep.
Yep.
Is everyone able to see the screen? I can't see. I see only blank screen.
Oh, sorry.
But now we can see.
It keeps getting paused for some reason. I don't know if like. Okay, can you see now?
Yes.
Yes.
Okay. Yeah. Was that clear?
But how exactly you do it? Like she was asking if we change, like the H character, we're gonna change to A, B, C, D, right? And then we look up the dictionary. Is that how you do it?
Yeah. So I mean, you could do it a number of different ways. I guess I could just show you like the code. So like this is how I did it for.
So if it's not in the dictionary, then it gets dropped from the queue. It's never sent to the queue, right?
Well, no, in this case, I mean, it depends on how you implement it. Like in this case, I have a function or a method that gives the adjacent word. So I'll just never return the words that are not in the dictionary. So like you could see, let's see. So I passed the word list here, right? And so I'm looping through the word list.
I think we're not able to see
we
your
don't
code.
see your code.
Yeah.
Hanif, can I write something on your screen?
Give me a second. Let me just. I think I'm not sharing my. Am I sharing my screen right now?
You're saying
whiteboard.
Oh, okay. Let me just stop that and then. Yeah, sorry about that. Can you see now?
Yes.
Right. So like I have a. There's a couple of ways you could do it, right? Like I have a function that will just give the adjacent words. And it'll take the word list. So it'll loop through, it'll actually loop through all the words in the word list and it'll count the differences. If the differences is less than 2, right? Because like if 2 words are adjacent, then they can only have like, let's take for example, like hot and hit, right? Like if they're adjacent, then they have to have at most like one character that's different. And it has to be at the same index.
Right. So you're not actually doing something where you're taking the first character in hit and replacing, is it hit or which is the first word that you start with, and replacing with A, B, C. What you're doing is you're actually checking the dictionary first. So
Yes. Yeah. Because like.
Yeah. Because obviously that's going to be faster. Like shorter.
It'll be faster.
You're going to eliminate the number of options.
But I guess it depends. Like if your dictionary is like 500,000 words or something, then you probably don't want to do it that way. Like.
Then you want to do it the other way. Yeah.
Yeah. So does I guess I already kind of showed my code. Does anyone want to try coding this? Like this one's a little bit longer, but the best is kind of a like boilerplate. So. Did anyone want to try this?
I'd actually like to see your code, like if you can do a walkthrough.
Yeah, sure.
Part of the objective here is not just to understand how a problem is done, but to understand how people present it. Right?
Yeah, so I could do a walkthrough. Let me just make sure one more time. So my screen is visible now. You can see my code.
Yes.
Okay. So Right, so this is actually not necessary. It's for word ladder part 2. Let's minimize that. And I tried using a hash map here. It actually doesn't give any benefit. So let me like comment this out. Okay, yeah, just pretend like those are not there. That was kind of playing around. So the underlying algorithm is really just a breadth first search. And breadth first search, like, it's one of those, I think if you read Cracking the Coding interview, I think she says that like in general, you shouldn't try to memorize algorithms, but if there's like one that you memorize, like breadth first search like might be like a good one to kind of have the structure, the general structure in your mind, because it's hard to come up with on the spot if you're not familiar with it. And basically the main thing to remember is that you use a queue. So, and like any graph search, you also need a way to maintain the nodes that you've already visited. So the first thing I check is that the word list is not empty, of course, or sorry, that the word list contains the n word. Otherwise, if it doesn't have the ending word, then of course there's like no point in searching further, so we'll just return 0. Where in this problem, we only want to return the length of the path. And then, so I have this hash map called parent. Basically what this actually could have been a hash set, like a visited hash set. Sorry, is somebody typing in the background?
It's me.
Oh, sorry. Okay. Right. So you could use a visited hash set. That's normally what you do in a breadth first search. I went ahead and used a hash map, and I called it parent because it'll give you like the same information as the hash set, plus a little bit extra. So like this maintains uniqueness. Like once we start for the breadth first search. And it also, for any given node, it'll tell like what the parent of that node is. So if you, like when I start the breadth first search, you'll see like I add the current neighboring word and as the key, and then the current word in the BFS as the value in that hash map. So what it's saying is, like, let's say if we go from A to B to C, what parent gives us, like if we look up parent of C, it will equal B. And the reason I did it that way is because in the second like follow-up variation of this question, instead of returning the length, you actually want to return the actual path that takes you from the starting word to the ending word. Okay. So is everyone clear on that parent hash map?
Yep.
Yeah.
Okay. So then the next thing that you need for a BFS, so this will maintain the uniqueness. And let's not consider the variation. Let's just think of like the simple case where we just want the length of the path. This will allow us to maintain that uniqueness so that we're not just going in loops in the search. Then we have a queue for the BFS, and we put the beginning word onto the queue. And then what we want to do is we want to like count the layers of the breadth first search. So like a layer, meaning like, I guess I'll bring back the whiteboard real quick.
It's kind of a level by level traversal, right? The level.
Exactly, yeah.
Okay.
So, okay, can you see the whiteboard?
Yeah.
Yeah.
Right. So one, like, you could consider the starting word like level 0. Like, let's say this is like L equals 0. Right. And then all of its neighbors, like including this one, you could like think of as like level 1. And so on. Like the neighbors of the neighbors will be like level 2. And so what we want is we want to be able to count these levels as we're doing our breadth first search. So we need some marker or some like something to designate the end of a particular level. So what I do to show that, or to like track the levels, is I just put null. Hopefully you can see my code again.
Yeah.
So I put null onto the queue, and that marks the end of a level. Okay, so I put beginning and then I put null, which marks the end of that level, and then I'll have some more conditions for adding null after that. And then another thing I track is like the previous node or the previous word that I visited, and that will initially be null as well. So basically the idea is that if I have 2 nulls in a row, like if previous is null and current is null, then like that's like the end of the search, and I can break out of it. And then I have a counter, which is search depth. So that will be what I end up returning if we find the ending word, right? Because we, like if you see here, line 81, I have to check that we actually found the ending word, because it's possible that I just do like an exhaustive breadth first search on the starting word, and the given like dictionary is like it's like a disjoint set where I can't fully reach every single word in the dictionary. And if the end word is in a disjoint graph from the starting word, then I don't want to return my search depth. I want to just return 0, right? So once we actually go into the BFS loop, the while loop here, so we loop until the queue is empty, and at every iteration, so we just remove from the top of the front of the queue. That'll be our current word. We check if it's null. If it's null, there's a couple possibilities. So if the current is null and previous is null, then we've reached the end and we just break. Otherwise, we increment the search depth and we add null to the queue again. And let me pull up the whiteboard again to explain why. So this might be like the trickiest part to visualize at first. So like I put the beginning word on to the queue. So let me draw a queue. I guess it'll be easier to type this actually. Let me just switch to empty. So like, let's say hit is the first word, and this is my queue, and then I also add null. And then, so when I first enter the loop, right? So my current will be hit, right? So cur equals hit. So it's not null. So I skip this branch, and then I come into this else branch. So hit does not equal the ending word, which in the example is cog. So what I'll do is I'll skip this branch, and then I'll loop through all of the neighbors of hit, right? Which will be hot. What else? Help me out. So it's hot.
Dot, right?
Not dot, right? Because it'd be like dit.
It's the only one.
Okay, only hot. So right, so I loop through all of the neighbors, which in this case it's just hot. I check that the parent hash map does not already contain hot, which it won't because it's the first time I'm seeing it. So I'll add it to the queue, and then I'll add it to parent, and I'll make the parent of hot hit. Which again, in this case, like the hash map is not really necessary. It's more like to kind of prepare for the follow-up where we would actually want the actual path from the begin word to the end word. But now if you look at the queue, so it'll have hit, it'll have null, and it'll have hot. And then previous will equal the current. I'm not gonna worry about that right now. So then in the next iteration, so hit will be gone from the queue because we processed it. The next thing will be null. So now when the current node is null, previous is not null because previous was our starting word. So we will increment the search depth by 1, which again, I could have that as like a variable on my like notepad here. I guess I'll just do that just so it's.
When did that word get removed off the queue?
Right when we got to the end of the while loop, like so, or actually right at the beginning. So we remove it.
Okay, yeah. Sorry, I missed that line. Yeah, thanks.
We remove it from the queue and we process it like down here, and then we just go to the next iteration. So we never add anything back. The only things we add are the neighbors. So yeah, so we were here. The current is null. And then since current is null, we add null again. So our queue will now look like this. It'll have null, which is the current one, so it's technically not there. And then it'll have hot from before, and it'll have null again now. So what hopefully like what you can see now is that like at every layer, the thing that marks the end of a layer in the breadth first search is null. And that's why when current equals null, we can increment search depth by 1. So yeah, that's pretty much the gist of the BFS. And then at the end, we have to check that we found the word in case the graph is disjoint. So if we found it, I check that it's found here. I have this check to see that current equals the current word, the ending word, and in which case we just set found to true and we break out of the loop. And we return search depth if we found the ending word, otherwise we return 0. Does anyone have any questions on this problem as a whole, I guess?
Can you talk about the runtime complexity?
Yeah, so what's the runtime of just like a general breadth first search?
It depends on the number of nodes at each level.
Height of the tree?
Yeah, so I think it's order of v plus e, like order of the number of vertices plus the number of edges.
I think so too, yeah.
Yeah.
So, okay, so we have O of v plus e. So v will be like, vertices will be the number of, it'll be like the number of like outgoing vertices from our starting word, which at the worst case, it could be n, which is the number of words in our dictionary. And then the number of edges depends on like what words you have and like how they're connected, right? So, but you could think of it as like order n, unless you have like assuming that the number of edges is approximately the number of vertices, you could think of it as order n for the BFS. And then if you look within the BFS, every time I'm also calling adjacent words. So let's jump back to that real quick. So inside adjacent words, I'm actually looping through the entire word list again to find the adjacent words. So so it'll also, that's another.
How are you making sure that we don't repeat the same words again?
Yeah, I have the same question.
Have a map, right? That map, that parent keep track of the node that already visit?
So I think there's two things that you have to keep track or not repeated, right? Like in general in a BFS, you have to make sure that you're not repeating the same nodes over and over again. So that's what the parent does. So we check that if parent does not contain the key word, where word is like one of the neighboring words of current. So we check for that here.
Okay, got it.
That
Okay.
that avoids loops. And then I was thinking, so this is like why I had these lines here initially. Like I was thinking like maybe I could get some speed up if like instead of like recalculating this, I could kind of like cache the adjacent words. But this doesn't really give you any like speed up. Because
So
you'll never have, like you'll never see the same word twice because of the way that the BFS is. The way that well, actually, I guess you can technically, I guess, because you make that call before the if statement. But I mean, like in my runtime, when I submitted this on LeetCode, like adding this caching didn't make any difference. But I was kind of curious to see if it would.
So let's assume that you don't add a cache. So at each level, they're gonna call this adjacent word function, right? So that'd be another big O of n, where n is the length of the dictionary.
Yes. So like.
So
yeah, go ahead.
The code that we have written with the multiple for loop, right? Do we have a 26 character or more than that?
No, so I'm looping through the adjacent words of the
but finding out the adjacent word, what we did is
so to do that, I instead of like looping, like trying every possibility of like every position, and then checking if those are in the word list, and instead what I do is I loop through the word list.
Oh.
And I track the differences here. It would be so yeah. So that I don't think that changes. I guess
it's depend on the word list, right?
It would be slower if word list is really large.
I think the best
this
thing
works
is
if the word list is short.
So that n square right there, right? You have two for loops.
Depends on the size of word list.
Yeah, exactly. So if you go through each change one by one character and look up the dictionary, looking up is a O of 1. And going through each characters with the different character, that is you know, always, let's say the 26 character. So 26 character into the length of the word, right? Length of the word is 3, then it's 26 into 3. So that many option we have. And out of that, of course, we will remove whatever is not valid by looking up in dictionary.
That might be more, right?
I'm not understanding. I don't think this one. He's not generating all the possible moves. He's only iterating through the dictionary, so he's just cycling through it's actually cycling through every character of each word, which is still a lot of work, but it's not the same as generating all of the possible words, like quote unquote words, even though they might not be words.
Hello?
It's less than 26 characters cubed or whatever it is.
I think my connection is like kind of unstable right now.
Okay. I think
I think it's set to everyone.
Yes, we have to do time check because we are running over. But just one thing I want to add, it is not a cube. The reason is that at most we can change only one word. So, you know, basically we go at the first character and change it 26 different character, or only 25, not 26, because one is already there. So we change it to other 25, and with the other combination unchanged, we see whether that is available in the dictionary. Then we go to second character and do that. So it is not cube. Basically, we are not what we are doing is that each character we are changing one by one 25 times. And suppose the length of the original string is 4, then we are at most we are generating 100 different words, 100 possibilities, and then we filter it out by lookup in the dictionary whether it is a valid word or not.
Right.
Yes.
Yeah.
Okay.
Yeah.
So
yeah.
So
That makes sense.
yeah. So Bhavesh, how are we
Hanif,
doing? Yeah, go ahead.
sorry, Hanif, this is Sai. Hanif, I would like to share my code, but I mean, I know we are already running out of time, but maybe I
Yeah,
can,
so-
put it in the chat.
Yeah, you can.
If anyone can
Share
do
in the
that.
Slack, yeah.
You could share it in the Slack, and then if you want, like, I will like make a. So we have our GitHub repo. I'm not sure if everyone's familiar. We have this like meetup, SDE skills meetup handouts on code. So I'll post my solutions, and then like, if anyone else wants to like post alternate solutions, you could feel free to do that, and then like one of the organizers will merge your. Just make a pull request, and then somebody will like merge your. Merge that in.
yes, and chat won't be a good option because after this meeting and chat will go and there's no access to it. So if you have access to Slack channel, probably you might want to post there.
Yeah.
Okay, will do. Thank you.
Yeah.
So how much time do we have left, Bhavesh?
We are already over time. I mean, we don't have any limitation by we can continue meeting, we can continue everything, but our office time is over. So maybe we want to. Can we include this question in the next one when you do next, or is there something that you want to quickly go over it?
Yeah, I mean it's.
Or maybe we can just discuss the approach or something, and then we can call it done.
Okay.
Sure. Yeah. So it's kind of like
just one thing on the complexity for the previous question, right? Just for the clarity.
Yeah.
So the complexity is always depend on age and number of age and number of vertex, right? And in this case, the given graph is not actually the whole graph is not given. We are basically building the graph. So we might know the vertex. I mean, we can get the ballpark, right? Maximum vertex are as many nodes, as many numbers are there in the dictionary, but there's no way to ballpark the ages. So we know the formula, but it's very difficult to come up saying that what would the complexity in number because the ages are not known.
Yes.
The whole graph is not known. Basically,
yes.
we are kind of building the graph, exploring building the graph. So we can tell formula, but yes.
So here the graph would be as good as a tree. You start with the root and expand. So it's as good as all the nodes. So if I can tell how many nodes I have visited, that's as good as my complexity.
Yes, but you can't tell, right? Because it's depend on the edges. How many edges are there?
Yeah, you could have multiple like edges and could have like cycles and whatnot. So
cycles won't be there, right?
Yeah, you cannot have cycles. Yeah, I thought
you cannot have cycle, but you have to visit all edges. I'm saying. So if you see the general formula, right? O of E plus V for the breadth first search, right?
Yeah, you don't know what E is.
You don't know what E is.
Yes, but I can say like if I start with the hit, so I know like I can change H to 26 times, I to 26 times, and T to 20, and then also have a word list, which will define like how many states I can go.
No, states is fine, but edges you don't know. You don't know that I can derive a word.
Yeah, I guess
from how many directions.
True. That's true. There is like an upper bound on the number of edges, I guess.
Yeah, upper bound is basically we always say that there are like length into 25. Are there those the maximum edges from each word? Suppose there is a length of four character word. That means the upper bound of the edge at each node is 100.
From each node, but okay, yeah, fine.
Yeah, okay.
It is a separate comment,
but
yeah. So So any other last things on this problem?
No, I think that's fine. I think we should quickly go through question 4.
Okay. Yeah. So I have like one more problem here. Like we probably definitely don't have. I guess we're already over time, and it's like kind of like the most complex one. Does anyone like? I don't know if anyone's read it already. Like, does anyone like just want to say the technique that they would use to solve this one?
So yeah, I kind of read it, but I don't know if we can actually come up with an approach with less than 10 minutes for this. I'm not sure.
I think union find might work here because it's
Yes, and I was also want to point to Bhavesh. If we couldn't do now, this is a union find problem. We can take it tomorrow.
Yeah, we are gonna have a union find things. Yes, we can take this tomorrow.
Oh yeah, yeah, sure.
What do you mean by take it tomorrow? Is this daily?
Okay, so maybe just for the interest of everyone who doesn't know, this is the weekly meeting that we have converted online because of the coronavirus. But we do have a daily lit core session that happen morning 8:30 PST time. That happen daily from 8:30 to 9:30 from Monday to Friday. And then Sunday we discuss about some specific topic. There's no meeting Saturday. Saturday, this is the one we have. And Sunday we meet at 9 a.m. PST time. So last week we discussed about, last Sunday, we discussed about union find, and then probably this Sunday we are gonna discuss few problems related to union find.
Is that at the same link?
Yes, the link is same. Are you on Slack channel?
I'm not sure. I'd
Okay.
have to check.
Okay, so why don't you, if you can join the Slack channel and post hi in general, probably I can send you the detail about all the different channel there, and then you can find. Basically, you can connect all the things that we are doing there.
Yeah, we have the link on our handout at the bottom here to the Slack channel.
Bhavesh, one more thing to add, like we are planning to have one more session on Saturday morning, system design.
I see. Okay,
Yeah.
I didn't know that. Okay, thank you.
Oh, it's from next Saturday.
Okay, from next Saturday, not this. Okay.
Yeah.
Right.
So
Asim is going to do that. Yeah.
Yeah.
So Naga and I'm planning to start a system design because I think a lot of people are asking. So yeah.
Okay.
So
all right. So what we are considering is that we won't discuss Cube for right now, right? Is that so?
I mean, if we have to do a union find for this, then I think people should go through your recording from the last week. If people don't know the union find disjoint set, then visualizing this problem would be tricky.
Is on the Slack workspace, is there a specific channel we should be searching for?
Yes. So if you're on Slack, ping Bhavesh, he would add you to different Slack channels.
Yeah, I'll give detail about different channel. Anyone who want to know about more things, I have a simple compiler list of different channel that you should visit, and just ping me, message me, and I'll answer. My name is Bhavesh, Bhavesh.
Or you can ping, or you can search organizer. You can see Bhavesh there.
Yeah.
Okay.
So yeah, so Bhavesh, or let me put the recording of last week of union find. So because if doing this question, you know how to do union find, then that's a tricky approach because you have to do this pay rank ranking, which only you can visualize if you know how to do that algorithm.
Yeah, so we could like hold off on this one. That's fine. So what time is the union find session tomorrow? 9?
It's Sunday. Yeah, 9 a.m.
So basically, Bhavesh did a session last week on union find where he told all the basic concepts like what is algorithm, what are different approach, and basically tomorrow is where we are going to solve some problems. And that's what I'm proposing. This problem can categorize into that. Otherwise, we have to discuss what is union find, how the algorithm works. Then we can jump to the solution.
Yeah, that's a good point. Yeah.
So I will recommend looking that video. Let me find it. Or Bhavesh, is that handy?
Come on.
Yeah. Sure. I can post it in a Slack because this okay. You want to post here? I'll
yes,
just
some people are not there on Slack, so thought of putting it here. That's what I'm trying to find it.
Okay. Let me post.
Okay, I think I found it. Good song.
Someone is singing.
All right.
All right.
you got-
Yeah. So, yeah. Thanks everyone for attending.
Yeah,
Hanif,
thanks, Hanif. Yeah.
Thank
Thank
you.
you very much.
So
Hanif?
if you're interested,
Yes.
just come.
I saw that you're finding it difficult writing in the whiteboard.
Yeah.
If you have the touchscreen laptop, I think when I was giving Zoom classes, I find it very useful having the stylus. I can send you the link from Amazon if you want. It's really like a pen. I can try
Yeah.
to
Unfortunately, it's not a touchscreen laptop.
Oh, okay. Then
Yeah.